Let's start chapter 2, the derivative. We will learn about the concepts, rules, and its applications. Imagine there's a line passing through P and Q. We say this is a secant line, and we can calculate the gradient of this straight line, that k equals delta y divided by delta x, where delta y is the change in y-axis from P to Q, and so is the delta x, the change in x-axis from P to Q. But this tells us the average value, or the average change. And what if we want to know the instantaneous change at some fixed point, like the point P, for example? Then we should decrease the distance between P and Q until their distance approaches 0. We say the delta x equals 0. Then we will get the limiting position of the secant line. It becomes a tangent line. Then we say the slope of this tangent line k equals the limit when delta x approaches 0, and the numerator is fx0 plus delta x minus fx0, and the denominator is delta x. So then the secant line, which is the average change from P to Q, will becomes a tangent line here at P. That is the instantaneous change at some specific point, but here is at point P. And the notation, we can write the derivative as f prime x, or dy over dx, and dfx as you like, okay? So the geometric meaning of the derivative is the slope of the tangent line at the specific point on the curve. And we may understand it better when we learn physics. For example, if there is a displacement time graph and it changes like this, if we want to know the instantaneous change, for example at t equals 1 second, then we should draw a tangent line here, and the slope or the gradient of this tangent line is the instantaneous change of displacement at t equals 1 second, or we say this is the instantaneous velocity at this point, okay? And these are the basic derivative formulas. If there is a constant, then its derivative is 0. So it's easier to remember, all the constants' derivative is 0. And if we have a polynomial function, then the power is n. The derivative of this function is n times x to the n minus 1's power. So we just multiply the n here, and then the power becomes n minus 1. For example, if we have a function y equals x squared, then the derivative of this function is we multiply 2 by the x to the 2 minus 1's power, so it becomes 2 times x, and the power is 1, okay? And the trigonometric function's derivative is, for sine x, it's cosine x, and for cosine x, its derivative is minus sine x, okay? So pay attention to the minus sign here. This is for the cosine x. And for the arithmetic rules, if we want to sum the two functions, then the derivative of the sum of these two functions becomes the individual derivative, and we just sum them up. Okay, so if we have u plus v, this function's derivative becomes u prime plus v prime. And if we have a constant times the function, then we just use this constant times the derivative of this function, okay? So for example, we have x squared plus sine x, and its derivative becomes, the derivative of x squared is 2x plus the derivative of sine x is cosine x. For example, we have another function as y equals 9 cosine x. Then the derivative of this function is 9 times minus sine x, which is the derivative of cosine x. And if we have the two functions multiplying each other, then we use this product rule that uv prime equals u prime v plus uv prime. Pay attention to the common mistake that the derivative of the product is not the product of the derivatives, okay? They are not equal. And let's see an example. If we have this function y equals x squared times cosine x, so actually this u is x squared, it's one function, the polynomial function, and another function is v equals cosine x, which is trigonometric function. Then we have the u prime, which is the derivative of x squared, is 2x, and v prime equals minus sine x. So we have y prime equals 2x times cosine x plus x squared times minus sine x. And then we can rearrange it to get this function. So we have u prime times v plus v times u prime. Okay, so the shaded one are the derivatives, and those I didn't shade it, it's its previous function, is its original function. And what about the quotient rule? If we have two functions dividing each other, then we have the denominator becomes v squared, and the numerator becomes u prime v minus uv prime. And there is a mnemonic that we can, and there's a mnemonic that helps us to remember this quotient rule. That is low d high, low d, low is v, and d high is the numerator, minus high d low, high is the numerator and the low is denominator, over low, which is the square of the denominator. For example, if we have to differentiate the tangent x, which equals sine x over cosine x, so we have u equals sine x, v equals cosine x. Then we have the derivative of this tangent x is over low, so we can write it as cosine x squared. And the numerator becomes low d high, so low is cosine x, and d high, the derivative of sine x is cosine x, minus high d low, high is sine x, we don't have to change it, and d low, it's the derivative of cosine x minus sine x. Okay, then we can simplify it as the cosine x squared plus sine x squared over cosine x squared. And we have this identity rule, they equals 1, so it becomes 1 over cosine x squared, which is secant squared x, because we know that the secant x equals 1 over cosine x. It's a little bit complex, but as long as we use these rules correctly, we can find out the answer. And then it comes to the chain rule that is used for the derivative for composite function. For example, there is a composite function y, and the outer function is fx. The inner function is gx. So y equals f gx. Since this is a complex function, so we can write it as dy over dx is dy over du times du over dx. They are equivalent because we can cancel the du here. Okay? So we have dy over du, which is f prime gx, and dx over d, and du over dx is g prime x. So the strategy is, first we should identify the outer function fu and inner function x. And then we differentiate the outer function without changing the inner function, then differentiate the inner function. Finally, we just multiply the results. Since we multiply these two derivatives, so we call it the chain rule. So it's like a chain, it's consecutive. So now let's see an example. If we want to find out the derivative of y equals the cubic of 7 minus x squared, so we first identify the outer function as the polynomial function u cubic, and the inner function is 7 minus x squared. So we differentiate each function. The outer function's derivative becomes 3 times u squared. The inner function's derivative becomes minus 2x, since the derivative of a constant is 0. And then we just multiply them. It becomes 3u squared times minus 2x. But we should substitute u as 7 minus x squared here. So it becomes minus 6x times 7 minus x squared, and then squared. Okay? What about the derivative of exponential and log? So the derivative for the exponential function is itself ex prime equals ex. This is for the natural base, and the general base is ax prime equals ax times ln a. And for the logarithmic functions, the natural logarithm, the derivative of ln x equals 1 over x. That's pretty simple, yeah. And the general logarithm is equal to x. In the general logarithm, the derivative log ax equals 1 over x times ln a, okay? So now we can practice more the mixed function problems. For example, the first one, y equals x to the 4th power plus cosine x. So we can recognize it as the sum rule and use the basic formulas. It becomes 4 times x to the 3rd power. It becomes 4 times x to the 3rd power minus sine x. And for the second problem, ln cosine x, that is a complex function where the outer function is ln x and the inner function is cosine x. So we should apply the chain rule. So the derivative for the ln x is 1 over x, but pay attention to not change the inner function. So it becomes cosine x, the 1 over cosine x, times the derivative of cosine x is minus sine x. So we get minus tangent x. And the last problem, these are the two functions dividing each other. So we use quotient rule. That is the square of the denominator, x plus 1 squared. And the derivative of the numerator is 1, and not changing the denominator, x plus 1, minus changing the numerator, x minus 1, times the original function of the denominator, 1. So we got 2 over x plus 1 squared. And now let's see the application, how to find a tangent line equation by using the derivative. Now, since we know that the derivative of the function at one point is just its slope of this tangent line, so we can know that the slope becomes x prime x0, and then we know that this fixed point is x0 fx0. Since we know this fixed point and the slope, we can find out this line equation here. For example, if we want to calculate the tangent of the tangent at point 1, 1 of this y equals x squared function, then we first find out the derivative is f prime x equals 2x, so we got the slope at x equals 1 is f prime 1, which is 2. And then we substitute this fixed point into the formula. That is y minus 1 equals the slope 2 times x minus 1. So we get the tangent line is y equals 2x minus 1 at this point, okay? Now we can wrap up all the stuff we learned today. So the geometric meaning of the derivative is the slope of the tangent line. And the physical meaning is the instantaneous rate of change, for example, the velocity of displacement time graph. And the definition is the limit of the difference quotient. And these essential formulas, you have to keep it in mind after class. They are quite useful when we're doing the differentiation. And there are arithmetic rules, especially the product and the quotient rule. They're a little bit complex, but as long as we practice more, we will get familiar with them, okay? And the chain rule are applied when we're doing the differentiation with the complex functions. So we just multiply the derivative of the outer function by the derivative of inner function. Okay, then the problem solving one, we can identify the function structure and select the appropriate rules, and then we can apply the rules systematically and simplify them. And finally, we can learn how to calculate the tangent line passing through one point. So we first know this fixed point, and then we can calculate the gradient or the slope by the derivative at that point, x prime x0. So we can write the straight line function as y minus y0 equals the slope times x minus x0. Okay, so that's all for today. Bye bye.